Good to see familiar faces from before. Thank you for attending. My name is Germán. I'm Developer Relations at SAFE. And today I would like to share with you what we are building regarding the ERC 4337, how we are integrating it with SAFE, thanks to the SAFE 4337 module. So first of all, I would like to ask if you have heard of it before. Please raise your hand. Okay, very good. And I guess in the last couple of months, even year, we've heard a lot of new terms regarding the ERC 4337, right? And now it's our turn at SAFE to integrate it, or to have support for it. In this workshop, I will talk a little bit about the benefits of the ERC 4337, but I see that most of you are familiar with it. Then I will cover how the SAFE Smart Account structure or architecture allows this. I will show what the SAFE 4337 module is and how it is connected with the different actors and the 4337 stack. And finally, at the end, we will see a demo executing a user operation, getting it sponsored with the permissionless JS library and the Pimlico infrastructure. So let's start with the or some of the benefits of the ERC 4337. And apart from the ones that are inherent in, for the smart accounts, we have, for example, flexibility of payments, where users can decide how to pay for the gas fees. They can pay in ERC20 tokens, they can pay in the native token, they can even get their transactions sponsored by a third party. There's also freedom of authentication, because it enables different ways of authentication, like multi-signature or passkeys, or maybe quantum-proof mechanism. And also, it provides decentralization, avoiding the lock-in of a single relayer technology by supporting different accounts and different providers. So let's see how the SAFE Smart Account architecture looks like. It all starts with the core contract, the account itself, the SAFE. And you may know SAFE, it's a modular smart account. This means that it supports, among others, modules and fallback handlers. There are some more that we will not cover in this workshop, but here, for example, modules allow to extend the functionality of the SAFE by implementing some logic in this module, and modules have access to execute transactions in the SAFE. They can be used, for example, to implement recovery mechanisms, different ways of authentication, and very soon we will see how they will help as well integrating the 4337. Also, we have the fallback handler. The fallback handler is a contract that can be enabled in the SAFE, and whenever a call is received in the SAFE account, if there's not a function implemented that is called in the contract, it will fall back to this contract, the fallback handler, and see if it is implemented there. And if it is, it will execute it there. This is very helpful when we want to integrate standards that are or support the standards that come out in the community, and they are not implemented in the main account, but they require the implementation of new functions, like this case. Regarding the SAFE 4337 module, we need to enable it as a module and also as a fallback handler. The module will allow this module to execute SAFE transactions, and the fallback handler will allow to receive some calls that are sent to the smart account. But just to clarify the difference between these two slides, it is just one module that is enabled with two different roles. So let's see now how the Safe 4337 module works together with the account and also the other actors. So here we can see, first of all, this is the validation step. Later we will see the execution step. But we can see the different actors in the 4337 ecosystem. We have the bundler, the entry point, an account, in this case the Safe Smart account, and then we have a target depending on the user operation and the transaction that is executed. So it all starts with bundlers submitting user operations to the entry point. Then the entry point will iterate on all of them and first validate them and secondly execute them. So first of all, let's say we have just one user operation. It will be sent to the account. Here the Safe proxy, your personal account, will receive a call of a function that is validate user operation. If you remember, Safe is not implemented or giving support natively of this CRC, but using the module. So we have the Safe 4337 module implemented as a fallback handler that will be able to handle this call. So the Safe proxy will forward the user operation validation to the module. And now the module will do two things. First of all, check that the user operation hash was correctly signed by the owner of the account. And secondly, and if needed, it will trigger a payment because it is also a module and it has the ability or the grant to execute Safe transactions to perform the fee payment to the entry point. After successful validation, the entry point will now call the account to execute the user operation, so calling the execute user op. Again, this method is not implemented natively in the Safe, so the Safe proxy will forward the validation to the Safe 4337 module. And now the module will call the Safe to execute this using the exec transaction from module. And finally, the Safe will actually execute this transaction, whatever it does. So some resources that can be helpful for you, just sharing 4 repos. The first one is the Safe Smart account, where you can find the contracts of Safe. All of them are in the ETHGlobal organization. The second one is Safe modules, where you can find the implementation of the Safe 4337 module and some examples using it. There is the Safe deployments, where you can find where what are the addresses where Safe is deployed depending on the networks. And the last one, the Safe modules deployment, you can see where the Safe 4337 module is deployed, what networks, and what is the address. So now let's do a quick demo sponsoring a user operation with Safe and Pimlico using the permissionless JS library. So there are some steps we need to do. If you are familiar with Pimlico, can you raise your hand? Okay, cool. First of all, we need an API key that will allow us to interact with Pimlico API, to interact with the different actors of the ERC 4337, like the paymasters, the bundlers, etc. And we need a private key because we need a signer to deploy a smart account, a Safe in this case. Once we have these two things, the permissionless JS library allows us to create different clients, like a public client. We are using the Gnosis chain as an example, but others can be used. So the public client will allow us to query that network, then the bundler client using the API provided by Pimlico and our API key. We can call the API methods related with bundlers, and the same with the paymasters. Once we have all these clients initialized, we can now create a signer or whatever you want to do this, but this is the simplest way. The permissionless JS library is providing a function, private key to account, that will generate a signer, but again, you can use your preferred way. And now, here is the interesting thing. There is one function, the signer to save a smart account, that will counterfactually give us, or it will return a counterfactual save. This means that it's a save object that is not deployed yet, but we already know the address. And to do that, we can pass different parameters. Some of them are optional, some of them are not. It's important that we use the version of the save, the 1.4.1, which is the one supporting the CRC. And regarding the address and the salt nonce is a random number we can use to generate different addresses of our save or future save. And the address, we can skip it in case we already, we can skip it if we don't have a save and we want to deploy it, or we can use it if we already have a save and want to initialize it. So once we have the save account object, we can create a save account client. And this will work using VM like a wallet client, but with our smart account now. And this is returned by the create smart account client, where we are passing some properties, the ones you see. After that, we can get the gas prices using the bundler client and the method get user operation gas price. And the last thing, if we want to execute it, we can use the save account client we initialized before, call the method send transaction, and here we can define our transaction. If we want to send some 0.00 something native token to a specific address, we can specify some properties related with the gas, and we will get the transaction hash. If we didn't have a save deployed, it will deploy the save with the 4337 module set up and execute the transaction we are triggering. If we already had a save deployed, it will just execute this user operation. The cool thing with this is that because we are using the Pimlico infrastructure, we can use their dashboard to put some funds there and pay for the transaction fees in all this process, and we don't need to worry about that. So here we have, well, like the code you just saw. I have commented the address because I don't have a save, and I'm using a random salt nonce when defining our save. So I can just run this, and I just have a signer and some keys, access to a network via the Pimlico API. Here it calculates the save address, which is not deployed yet, and at the very end, it executes the transactions that I defined previously. So that is for the demo. And now we have a surprise for you during the hackathon. I hope you liked that we are offering to you sponsored user operations. So yes, if you are planning to hack with any of these chains like Gnosis, Arbitrum, Base, Celo, Optimism, or Polygon, we are providing some codes you can use in your implementation of the permissionless library. Sorry, you can scan this QR code. This will send you to our hackathon success guide with this announcement, and you can get this sponsorship policies. It's not working. Okay. And for the hackathon bounties, we have 2 of them. We have $10,000. The best one, which has allocated 8K, is for the 4 best applications that integrate the SAFE 4337 module. And there are some requirements, for example, deploying or connecting existing SAFE accounts, executing SAFE transactions, and supporting SAFE version 1.4.1, and use the SAFE 4337 module. Those would be the requirements for the first bounty. And the second one would be for the best SAFE Farcaster frame. Some requirements like deploying or connecting existing SAFE accounts, executing SAFE transactions, and the frame should be shared on Farcaster and available for us to check. Nice to have if you also want to integrate the SAFE 4337 module in the Farcaster frame. That would be great. So we are on Twitter at SAFE. We have some docs at docs.safe.global. We have updated them with more information about the 4337 if you want to check them. Discord, forum. So thank you very much for attending.